Hello and welcome to 8.7 for algebra. We're still factoring quadratic equations, so please pause and make sure you have attempted these first three problems about factoring. So I'm going to give you the answers in just a moment, so please stop the video and try the first three problems. Okay, the first problem is probably the trickiest one. You need to put it in standard form first. And for our product sum, this time we're dealing with 24, and we need multiples of 24, and notice it's 3 and 8 that subtract. This told us opposite signs, the larger number's negative. So of 8 and 3, I need to figure out how to multiply to get the larger number negative. And when you do the FOIL method, outside, inside, you end up with negative 8x, positive 3x, so that's what will make negative 5x. So I will admit that number one was a little bit tricky. If you still had trouble with it, even after you see the correct answer, let me know in class. The second one was fairly easy. We're solving for the roots, so we have to decide what makes each of those 0. The third one, once we brought our 12 over, we know they're the same sign, both positive. Let's go back to number 2, opposite signs, the larger number is negative. And number 4 is just an exercise in solving for h. So it's just making sure you know how to manipulate an equation. So first I multiplied both sides by 2 to get rid of my fraction, and then I divided both sides by the sum of the two bases, which cancels, so h equals 48 over the sum of the two bases. It's a funny looking equation. It doesn't look like anything we usually work with, but that is how you would isolate h. Now we're ready for the new material of 8.7. If a polynomial is prime, we say prime when it cannot be factored. So when we have a polynomial that cannot be factored, we call it prime. When you have ax squared, which is what we've been dealing with, x squared plus bx plus c, but in our new section 8.7, what's new about 8.7 is the a here cannot be factored out. When we take out the greatest common factor, we're still going to have a number besides 1 as our a. So this is really what is the new challenge for us today. So what we're going to have to do, here are our steps to approaching it. They follow very similarly to the factoring steps you have that I gave you in class. We say a times c. That's going to be our product. So when we set up our product sum, the product is going to be a times c, and then the sum is still going to be the number b. Let me show you how that looks. So we have to find a pair of numbers that match the product and sum, and then we replace the b with those. So instead of 1b, we're going to have the 2, and we'll factor by grouping. Alright, so here we have, first thing you ask yourself, what's the greatest common factor? Man, if I can take out a greatest common factor, it's going to make our life easier. But there is not a greatest common factor between 5, 27, and 10. So my product is actually 50. 5 times 10. So I need multiples of 50 whose sum is 27. So I am going to start with, well, I don't know about you guys, but I always think of 2 and 25 for 50. Hey, and 2 and 25, guess what? Their sum is 27. So that worked. My very first guess works. So we'll rewrite the problem. We still have 5x squared. Now instead of 27, I'm going to write 2x and 25x plus 10. Look, 2x plus 25x is the same thing as 27x. but I broke it apart because now I'm going to factor by grouping. Except I wrote them backwards because I can't factor a 5 or a 2 out. Let's rearrange, and that's going to happen sometimes. So the more you practice this, the better you're going to get at saving yourself some steps. Now I can factor out a 5 and an x. This is just factoring by grouping. I'll have an x left and a 5 left. So what can I factor out of 2x and 10? I can factor out a 2, which thankfully I have an x left, and I'll have a 5 left. And remember, when you factor by grouping, you want to have in parentheses the same number. So I now can factor out the x plus 5, and I have 5x plus 2, and that's how you would factor number 1. And again, you do FOIL method to check your work. On number 2, when I first start off with my greatest common factor, I do have a greatest common factor. It's 4. Yay! So I can take out the 4. I have x squared plus 6x plus 8. And there's not a number. A is an understood 1. So this is old school factoring, multiples of 8 that add, because it's same sign, both positive, add to give me 6. How about 2 and 4? And I'm done. So they're not all going to be as complicated as number 1. Flip over to, I'm going to work 3 of these, and then I'm going to leave 3 for you to work. So starting with number 1, can I take out a greatest common factor? I wish that I could, but there is not. Between 3 and 26 and 35, there is not a greatest common factor. So I always like to write it down just to show myself that I checked. Alright, so I now need, for my product and sum, 3 times 35 is 105. That's the product I'm looking for, and I want their sum to be 26. So multiples of 105, since it ends in 5, let's try 5. 5 goes into 105 21 times, and guess what? 5 plus 21, it makes 26. So it's my lucky day. It's not always going to be the very first number that I try. So I'm going to rewrite 26x to be 5x. Actually, I'm going to be smart this time. I'm going to write 21x first, because 3 and 21, 3 can be factored out. So put your 21 with your 3 and your 5x with your 35. Notice how I caught that mistake right there, so I wouldn't have to write it twice. So now I can factor out a 3x. That leaves me with x plus 7. Plus, factor out a 5. That leaves me with x plus 7. Thank goodness. I always want there to be the same number in parentheses. So when I factor out an x plus 7, I have 3x plus 5. And that would be the factored form for number 1. Alright, number 2, is there a greatest common factor between 2, 3, and 9? I'm afraid there's not. So my product is going to be 2 times 9. It's negative, so it's going to actually be negative 18. My sum needs to be negative 3. So we're going to have opposite signs this time. So 2x squared, multiples of 18. Let's try 2 and 9, and the 9 would be larger, so I'll keep it negative. When I add those, that gives me a negative 7. I don't want 7, I want 3. So let's try 3 and 6. Hey! When I add those, I end up with negative 3. So it wasn't the first try, but the second try. And again, I'm going to be careful which way I write these. Since I have a 2 here, I'm going to write the even negative 6x and a positive 3x, because remember, I want them to add to give me negative 3 right here, and then copy down your negative 9. So I can take out a 2x, so I have x minus 3, and I can take out a 3, which leaves me with x minus 3. So x minus 3, oh no, x minus 3, and 2x plus as my final answer. All right, greatest common factor between 24, 22, and 3, there is not one. So now we need to multiply 24 times 3 for our product. And 24 times 3 is 72. And our sum needs to be negative 22. So let's start with the fact that it's going to be same sign, both negatives. So let's start dividing by 2. So 2 goes into 72, 36. So negative 2 and negative 36 do not add to be negative 22. Let's try 3. 3 goes 24. They do not add to be 22. So let's try 4. 4 and goes 18. Hey, we've got a winner. When you add negative 4 plus negative 18, you have negative 22. So this is my solution for negative 22. So 24x squared, and they're both even. I am going to write my 4 first, just because I don't see a reason why not to until I get a little farther into it. And negative 18x, and then your plus 3. So between 24 and 4, I can factor out a 4 and an x, and that leaves me with 6x minus 1. Now here's where it's going to get tricky. We have two negative signs. So let's factor out, oh, that's not supposed to be negative, that's supposed to be plus 3. I think it didn't, sometimes my pen doesn't catch. So if I make this negative 3, then positive 6x would make that, when I multiplied, negative 18x, and that's what I wanted, 6x. And then a negative 1, because negative 3 times negative 1 would make that positive 3. So good. I have 6x minus 1 to take out of both sides, and 4x minus 3. And that would be the factored solution. And I'm going to leave the 3 for you to try on your own. At the bottom is a physics problem that shows you how you can use factoring to solve real world problems. Okay, I'm not sure how we pronounce this man's name, but his science class built a model rocket for a competition. When they launched their rocket outside the classroom, the rocket cleared the top of a 60-foot high pole. On its descent, it landed in a nearby tree. If the launch pad was 2 feet above the ground, the initial velocity of the rocket was 64 feet per second, and the rocket landed 30 feet above the ground. How long was the rocket in flight? Use the equation h equals negative 16t squared plus vt plus h sub 0. So I am no physicist, but I do know h stands for your height, v is for velocity, and the h sub 0 is the initial height. So based on the information in this problem, our height at the end of the launch was 30 feet above the ground, our velocity was 64, and our initial height here, it says it started at 2 feet above the ground. So I plug everything into the equation they gave me. I rearrange the problem so that I can have it in standard form. I take out the greatest common factor of 4, and so now my product is going to be 4 times 7, which is positive 28, and my sum needs to be a negative 16. So they're going to be same sign, both negative. So let's look for multiples of 28, and the first one I try is negative 2 and 14, and that adds to be negative 16. So we rearrange the problem, changing negative 16 to negative 2t, negative 14t plus 7. So when I get this, you may want to pause the screen into its complete factored state. I'm trying to find what makes it equal 0. And so my roots are 3 1/2 and 1/2. So how long was the rocket in